Welcome guys to another eBPF Chirp episode. Today with us is Henrik. He's a CNCF ambassador. He's also a staff engineer at Dynatrace and also a blogger as myself. Make sure to check it out. If I forget to pinpoint it out at the end, he has his blog called Is It Observable? Really cool stuff. Make sure to check it out. So Henrik, you're a CNCF ambassador. Help me understand and the listeners, what does this even mean? How does one even become a ambassador? So yeah.
I think if you are involving in the open source community and you like projects, you want to contribute, then CNCF ambassador is one of the roles. So you could basically at the end, the idea of an ambassador is to spread out the good message about CNCF. And now it's more about promoting also projects. So there's a lot of project under the CNCF landscapes, and those projects sometimes deserve a small help just to be promoted, to explain, to increase the overall adoptions over the cloud native space, because at the end there's so many projects coming out or coming in the landscape, so you have to follow that. And I think that's fantastic. So if anyone wants to be a CNCF ambassador, then the things that you need to do is basically, first, if you like to present into conferences, then if you like to produce content, or also contribute to projects. So helping them, I don't know, improve the docs or improving anything like this, you could basically apply. So there's 2 series of registrations or submissions, or how to name it exactly. It's pretty much aligned with the KubeCon. So usually you apply your candidate 3 months before KubeCon, something like this. And then they basically give the names of the new ambassadors. And then KubeCon is the right excuse to meet the other ambassadors, get briefed. And then, so there is one for Europe and one from the US perspective. So there's 2 cycles per year. And then, of course, once you're ambassador, you have 2 years program. And then if you can, of course, apply to renew your ambassador program membership to then continue this if you're still up to that and you have time to invest yourself in helping those projects. But I think it's a great thing. Cloud Native community itself is amazing, and then just a small group of ambassadors. It's also another community itself, so it's pretty nice to know all those peoples.
So it's like contributing to projects and then also applying as an ambassador, and basically go either the way of still helping maintain the projects or content creation. There's like many ways, if I understand it correctly, right?
Yeah. The idea is at the end, it's more about blog post, anything that could basically help the community to understand something. Of course, we don't ask everyone to know all the projects around the world. If you have one project or 2 that is pretty much popular, then you can just focus on this one. But the idea is that you need to deliver some like a certain level and certain number of content, either video or talks or blog posts or podcasts or whatever. That's what is behind the scenes.
Yeah, and that's only one part of the things that you do. Obviously, I checked a bit your portfolio. You have like extensive experience when it comes to performance engineering, if I can call it like that, and also probably large scale deployments, like figuring out how the system, like a large scale system, is operating in itself, and where are the potential bottlenecks. So help us understand maybe this part, performance engineering, but also how you basically fit it, like how you do the side stuff.
So now I'm not doing full-time performance engineering, but I spend, let's say 80% of my career as a performance engineer. Performance engineer is I think it's an amazing practice, because of course, when it comes to testing or engineering stuff, you always this boring task about building simulation, because at the end you need to simulate real interaction with the system, because at the end performance engineering is like you generate a simulation that will reflect still real interaction with the app. So then you can actually measure how those processes, those database calls, or any interaction with the queue or anything, how it behaves. And then if you increase the load, also how your systems handle this. So there's always this, I would say, not interesting piece, which is the scripting or building those automation or simulation, but it's a small piece. People are always thinking about only this, but the role itself is larger than that. Once you have something going wrong or really bad, then you say, okay, where should I start? And then you start digging in. You look at different layers, and that's why I think it's an amazing practice in a sense. You learn very quickly expertise about reverse proxy, DNS, any switch or routing components that could be applied in your systems, and then web server or application servers, container, Kubernetes, databases. I mean, it basically depending on the projects that you have to handle, then you discover something. So I have the chance to test some ACP world in the past. I didn't like it, but at least I have some knowledge about ACP, so I can talk about it. Same thing for Cisco. I've been doing a lot of large, very popular European league that happens at the moment. We did that. They were doing live stream on their live games, so we were simulating millions of users, seeing the quality of the streams. Then you suddenly you start touch something different, because streaming is a different way of handling the notion of performance, because it's not about response times anymore. It's something else. But yeah, it's amazing. I also did some IoT stuff, testing a lot of connected cars, and or for Qatar, it was the police. They had their car with a lot of devices, so you can keep track then where they are. So we were simulating false GPS routes into the desert, and it was fun. But then you started digging in other problems. So I think it's a great way of starting to understand a broad scope of technology, and then because you're running into pressure, so you have to, I don't know that stuff. So then you don't ask yourself, then you just dig in. You just take the whatever is materials available, and you start going through the content, understanding how it works, how the process, so basically retro-engineering how the component works. So then to come up to like a decent conclusion, and then of course you look at the graphs and everything. So behind the performance aspects, there's so much about observability. And when I did that role, I would say observability was not as mature as it is now. But yeah, we were dealing with a lot of logs, a couple of profiling, there were a couple, of course, metrics. Of distribute traces was there, but it was depending on the product. But yeah, and then everything, you pull up everything outside of because they didn't, at that time, there was no solution that had everything in one box. So then you were cross-correlating everything. So you were doing a lot of bash and storing in databases. And so, yeah.
Yeah. So the way I see it is like, okay, yeah, you have this system, you simulate the load on it, but then it's basically just about the observability and trying to make sense around that observability. What was the feedback basically that you received from the system? And what I see here is there's a lot of potential for eBPF. Obviously, you can do a lot of observability with eBPF. You can do also a lot of observability if you do custom instrumentation inside your code. There's obviously like this downside that you actually need to change the application code, etc. But what I'm interested is can you outline some use case where user space observability, if I can call it like that, just wasn't sufficient, and it's something that you had to rely on eBPF to export you this data to make sense of certain.
So I was a big fan of Brandon Gregg's work, because he was also a performance engineer. Then just because of on your new modern cloud provider architecture, you don't have a server with the motherboards and CPUs and disks close to it. It doesn't work like this. You have a disk hub connected to the wire to another stuff, and then you have some CPU that is shared. Basically, every component is, so then the notion of waiting time, because in the CPU you have it's working, then it's waiting, and then it's idle. And waiting, sometimes there's so many different reasons why your CPU is actually waiting. So that's why we were using the toolings that Brendan Gregg came up a few years back to understand, okay, so if I have a CPU wait, what am I actually waiting for? Is it disks, IO? Is it networking? Because for some reason we're going through the network to get some access. And then you have a more understanding on why we have that spike. Is it actually related to the app, or is it something more about the design of the actual architecture? And I think that was super useful to get that type of level, because with the traditional tools like the CPU average or CPU percentage, it usually doesn't mean much. So you need an extra layer of abstractions to understand it. And then also the other piece that I thought was very powerful is everything about networking. I think on the networking side, either you use this, I mean, traditional, you have the chance to get a like a TCP dump and you use Wireshark and then, okay, that's great. But sometimes you don't have that. So having a solution that lively receive, basic sniff the packets and see where it goes, then it makes your life so much easier, because sometimes you can spend just time for nothing. And then with eBPF, it makes a lot of sense for here.
Yeah, because also suddenly, as we are like basically traversing from legacy CNIs to eBPF based CNIs, suddenly the whole networking stack, if I like can illustrate it, is mostly implemented in eBPF. So tools like TCP dump cannot like tell you the best image what's actually occurring, because the networking part is actually occurring much earlier in the
But it's the same. Another thing, because even at the moment we have Cilium and Humble that gives a lot of great details. But still, I've been doing a lot of API gateway stuff. So you create a gateway, you create the HTTP route, you create the gRPC route, you start doing some service-to-service communications, and then nothing works. And then even with Cilium Humble, you don't get that. I mean, what I would love to, I mean, I think I'm going to try to build it, but what I would love to see it is basically, I'm putting it, something related to actually the policies or the network policies that we've implementing. I mean, same thing for a service mesh. If you look at Istio, any services on the market, we deploy policies and then we cross the fingers because we have no way of actually visualizing this policy and where it's been connected. Did it connect to the right networking path or not? And then this is just painful. And I think we are pretty much lacking in that space. Maybe there's a tool. I don't know. If someone knows it, I would love to have that tool. But from my perspective, I think eBPF could be a good player. But then I need to figure out how we could attach to this, I would say, user space CRDs in Kubernetes.
Yeah, but also, since you mentioned network policies, for example, layer 7 network policies, there are two ways I saw it being done. So one is obviously user probes, and the second one is redirection to like an Envoy proxy or something, and based on that, the rules are enforced. What's your view on that? Like, which one to choose? Like, which one is better? Is there even such thing? Like,
I mean, if it's pure layer 7, I'm trying to follow, I'm in the specific of the Kubernetes space. I don't want to fall into the specifics of Envoy. I try to use anything that it's like OpenTelemetry for observability here. The API gateway provides those standardized objects to configure things, and then if you want to have a custom policy, then you can attach still the other product that could make the stuff. But yeah, I'll try to, because Envoy is a beast when it comes to doing a lot of fine-grained layer 7 changes, but it's really specific. So then when you have invested a lot of time on Envoy and suddenly says, oh, today I want to use, I don't know, a K gateway, or I want to use Kong, or and then it's you have to relearn everything. So that's why if we start to figure out that those layer 7 stuff, I can do it through whatever CRDs that they are providing on the project, then I would definitely do that in that way, for sure.
okay, let's move on to Dynatrace. How does Dynatrace utilize eBPF? I did some searching, like you'll use it for service discovery. There's this tool called NetTracer. Can you outline not only like, okay, these are these tools, but actually also how it evolved, how when eBPF came into the picture, how it changed the mentality of Dynatrace?
So it's an amazing question, and I think as Dynatrace, we have a large number of customers, both into either very cloud native ready solutions, customers, or that are still using legacy systems. So we need to provide both worlds. In the legacy systems, or I say bare metal environments, we try to avoid eBPF, because then you're pretty much dependent on which kernel, which systems, and then it's just cumbersome for support and maintenance, and then it becomes super over complex to set up everywhere. So we try to put eBPF in more, I would say, control environment, and I think Kubernetes, at least in the managed world of Kubernetes, it's simpler, because at the end you know that any of those cloud provider in the world will give you, of course, one of the latest kernel, and not a very old and updated kernel, and then you won't be able to get the details. So for now, we mainly use it. We used to to have it for more net tracing. So basically all the communications from the community perspective. And from the rest, we rely on we have our own technology, but we also support open telemetry. So whatever comes in through the open telemetry wall, we try to support it as well. So that's why I think as of now, a lot of things rely on distributed tracing to rebuild this service dependency map, and also with the logging and all the tracing, whatever context that is passed through the different signals. But yeah, in eBPF at the moment, we try to use it in a very tactical way. We want to use it, but we don't want to be limited due to whatever security policies that one big organization can say, oh no, this security context is forbidden, or this security is forbidden, we don't want. So we try to play smart. So just deliver pieces that could be done in an easy way without affecting everything. So if people has the rights, they can use it. Otherwise, yeah, let's forget it.
But are there like specific components that you redesigned in eBPF or push some, let's say, user space logic into kernel, or was it more of adding features on the side?
No, it was mainly for getting some like you said, the networking details. Also, that we have a research team on the security space that do a lot of things. They're doing a lot of improvement on the security areas. They come up with a new open source project called Honeypot. I mean, he was one of my colleagues was presenting at KCD Austria. I don't know if you see it. So it's so the project itself relies on either you have an existing runtime security agent, but it gets it. So it basically puts some eBPF traps. Way of detecting if someone took this Connie token, and yeah, so that's mainly where we are. But in our product, because we need to make sure that to be tactical to cover both worlds, if we have to maintain one component, we want to make sure we don't over consume put too much resources everywhere, because otherwise, if you have two technologies or two different way of doing things, doesn't make sense at all. Especially we also have to follow the trends of the market and be reactive on that.
Yeah, exactly. The question on that with eBPF, we're moving or basically also creating another data source beside OpenTelemetry data source or whatever Dynatrace is ingesting. And now at your agent, how do you like now sync this data? Or how do you like, is there a fine line where you say, okay, I don't know, metrics are from eBPF, traces are from OTLP? How do you do it? Yeah.
So at the end, what differentiates the source of data is just that the agent, it has a specific protocol that we have worked over the years. So the way it's exchanged to our tenant or our server is very specific to that protocol when it comes to the agent itself. But then the data itself, with the new version that we have Grail, it's just a unified storage layer based on metadata. For us, this storage stores metrics, traces, logs, events, topology informations. Everything is into that data lake. So then you can query everything in one query. You don't have to query metrics, traces. You can create one query that gets everything. For us, every data comes into what we have a named extraction layer. That layer, it's basically the front door of our ingest API. Once everything data that comes in, that goes through this technology, this solution called Open Pipeline, and then the solution will try to, based on the metadata, says, "Oh, I want to index it and put it with the right topology model that we have in our architecture," and then the data flows in. So that's why one agent or the Open Telemetry, for us, it's the same route. Everything goes to that Open Pipeline, and Open Pipeline will do the gluing the data together. And of course, user can create their own pipeline to customize it to the stuff. They have a lot of options to do that. And I think this is way, because at the end, as a user, for us, our primary goal is that the data that comes in from traces, metrics, and logs should be consistent and no differences with either it's from generated by OpenTelemetry standards, or an external component or agent, whatever, or our component is going to be the same thing. Doesn't make. It's just that if you have our agent, the experience is simpler. You get predefined modules and features that our platform provides. But then if you want to go with your own stuff, there won't be a major difference. Is that you will have to collect the data and send it to our endpoint, and then the rest will happen.
Okay, that's cool. Recently, I had a really interesting conversation with one of the engineers from Oligo Security, where he said like there's this separation between you have, if we talk about eBPF, obviously, you have eBPF for observing processes. You have, like, you can map it then to pods or containers, etc. You have this observability. But when an attack actually occurs, you say what the user perceives is, okay, this process did something malicious for whatever reason, but the user doesn't know exactly from where the attacker, let's say, come in, or from which line of code the attack actually sourced from. So what they're working on, their guy at Oligo Security, is basically mapping these kernel events to lines of code in
That's
yeah. And I just want, just out of curiosity, have you ever put any thought on that?
So on the security perspective, what we do is that we have our agent that do some security pieces, or you can use whatever agents. And then we are coming up to a standard called security events. We're trying to share that standards on the across the community. So then we have already defined 5 or 6 different type of security events, depending on if it could be vulnerability or threat detections or whatever. So you have a schema, and then when the data comes in, everyone can rely on it because it's going to be a standardized schema. So that's how we consider data. But to come up to your questions, at the moment, our agent is able to detect. So we have like a database of vulnerabilities, and then if the code is loaded and our agent is sitting there, then it says, this morning this has been a severity, and then we can basically point out where which user journey is involved into that vulnerability package, which component, which areas, because then we are in the actual, we know. And then because we generate profiling, we can also already point out to the actual code that is vulnerable. So it simplifies a lot when it comes to if you have to react fast and say, we have to change library, which user is impacted. Well, here you have the answer lively because of the agents. That's one thing. And then we don't rely specifically on eBPF to do that, but we released a year ago a technology feature called Live Debugger. And then this is basically, it's not like a debugging where when you debug in your develop on IDE, you put some debug flags, and then basically the breaking points stop the code, and then you can see the values. Here it's different. You want to enable a live debugging session. You see the code, you can put the breaking points as you want, same thing, but here there's no pose. There's nothing posing the code. So you could be in production, and then those breaking points will generate on the fly logs and events. So then it will be stored in our backend. And then once you have the details, because you saw that something is weird, you can disable the live debugging sessions, and then you can look at the data that you have collected during a time frame. So then you can say, okay, I got it. This variable is whatever value. It doesn't make sense. There's a bug here.
Cool. So when we're just talking about runtime security, we're getting almost to the end. I would say there were two sides when I talked to people on the cloud native days in Austria. There was one side that was claiming, you should do runtime security based on the alerting, and you should do runtime security by directly enforcing the rules and actually blocking the actual attack. So which side you are on?
I think it depends on actually the type of threat that you're talking about. If you have a well-known attack pattern, then blocking it will make sense. But then sometimes if you put something that will stop the process and you have something, your code relies on it, then it's going to be a mess, but at least you control it. I think that I like the approach that putting some fake tokens, fake files, fake endpoints to then, if someone reach out to those fake things, you get alerted, then you know that something happening, and then you can react and say block it. But I think in order to create those blocking events or stopping those stuff, you need to first collect and understand, this is happening, or maybe, this is happening because it's normal, because whatever code is doing that. Before being very aggressive, I would first having like a learning phase. I like the Cubescape approach, where you learn how the code behaves and then take action from there. So I think that is very smart, and I think we should move more towards that direction.
Yeah, towards SBOC. Yeah, this is what Constanza was presenting. Yeah, that was cool. So, okay, last question. Like, as a CNCF ambassador, is there any project that you think that in the CNCF landscape is slightly underappreciated, I should say, and you should think it should get more praise?
That's a really
Yeah,
good
it's
question.
large landscape, I know, but
I'm just thinking because there's so many projects. I mean, I'm a big fan of many projects. Um, I think that it's just I'm not going to answer definitely your question, but I would say that I think the problem is that sometimes we are engineers working on those open source projects. We see the value, but sometimes we have issues to express the values that people will understand it. So then the adoptions is slowing down due to that. So I think Inspector Gadget, it's a just insane project, and I think it took some time to get the right adoptions over on the market. And I think this project is you can do so much things with it, but I was surprised that people was really not aware of it or didn't understand everything that you could do with it. That's just an example. And I think if you need to have someone that looks at it and say, oh, this is this use case, and then start sharing it to the world, and that makes the difference.
and then maybe Coopscape will have more praise than Inspector Gadget, although Coopscape is using it under the hood. So yeah, I get it. Okay, cool. So thank you for taking the time. It was really great to meet you. So yeah.
All right, cool. Thanks.